Hey guys, so in today's lesson, we are going to be talking about quadratics and their graphs. For this lesson, you're going to need to be familiar with solving quadratics, and you're going to need to remember how to graph functions on the graphing calculator. I'm not going to be going in detail. I'm not going to be reteaching that to you, so I'm going to link the videos for graphing and solving quadratics in the description if you need to refresh your memory. And then for this lesson, you're going to need station 1, something to write with, and you will need a calculator. Cool? All right, so let's get into example 1. So for example A and B, these are things that you should know how to do already. So we need to solve this quadratic. So we have x squared plus 2x minus 3 equal to 0. Remember, we factor. After we factor, we get x plus 3, x minus 1, and it's set equal to 0. And then you solve for each part, and you should get an answer of x is -3 and 1. All right, graphing. I'm going to plug that function into the calculator, x squared plus 2x minus 3. Notice it's the same values that we have. One is an expression, and the other one is just an equation because it has an equal sign, but it's the same values. So pause the lesson, and I want you to go ahead and graph that function in the calculator. So after you graph it, you're going to get what I have on the screen. And you might be asking me, why are we doing this, right? We already learned this already. I want you to pay attention to the zeros. We have 2 of them, and we have a 0 at -3 and at 1, which are the same values that we got when we solved the quadratic for part A. All right, so I wanted to draw that connection. So moving on to the next part, the solutions to a quadratic equation matches the zeros from its graph. So you can solve quadratics graphically or algebraically, depending on what the question is asking. Next, let's move on to example number 2. So for example 2, identify the equation that best matches the graph. And we have a graph here with no numbers, and we have 3 choices. All right, so how are we going to figure this out? We don't have any numbers, but we can estimate what's happening with the zeros. So I know that I have 2 zeros because the parabola crosses the x-axis in 2 places. I also know that one of the zeros are negative because it's on the left side of my coordinate plane, and one of them is positive because it's on the right side of my coordinate plane, which means I have a negative and positive 0. So let's go through each of these choices and see which one of these gives us a negative and a positive 0 when we solve. All right, and all of the choices are already factored, which makes our life a lot easier. So for the first one, when you solve, you get 1 and 3 as your zeros. This equation is not the graph because for part A, we're getting 2 positive zeros, but in our graph, we have 1 positive and 1 negative. Let's move on to part B. When we solve it, we're going to get x equals to -3 and x equals to 1. This is a possibility because we have 1 positive 0 and 1 negative. When we solve our equation in C, we get 2 negative answers, so that's not possible either. Meaning that choice B is going to be our answer. That is going to be the equation that best matches the graph. Example 3. All right, so we have a graph, and the graph is facing downwards. It is concave down. And we know that this is a quadratic or a parabola because of the shape. So we want to identify the equation that best matches the graph. So for this, we see that the graph is facing downwards. And to me, that shows me that my leading term must be negative. So choice A, I have a positive leading term. Choice B, I also have a positive leading term. And then for choice C, I have a negative leading term, which means choice C is the best equation that will match up with the graph. So in your notes, anytime you have a quadratic with a negative leading coefficient, it's going to be concave down. It's going to open up downwards. And when there's a positive leading coefficient, like for example, 1 and 2, our parabola is going to be opened upwards. Our video was short and sweet for today. Let me know if you have any questions and move on to the next assignment.